Calorimetry. It is impossible for us to know the absolute enthalpy of any system because we cannot know the absolute internal energy. However, we can measure the change in enthalpy using calorimetry. Calorimetry is the measurement of energy transfer using a calorimeter, two examples of which are shown here. In using a calorimeter, we measure the change in temperature of the contents and relate that to the energy change. To relate the temperature change to the amount of energy transferred, we need either the heat capacity of the system or the specific heat capacity, more commonly just the specific heat, of the solution. The heat capacity is the energy needed to raise the temperature of the system by 1 Kelvin, or 1 degree Celsius. It has units of joules per Kelvin. We use the heat capacity when we have measured, or know, the temperature change of the system when a specific amount of energy is added. The equation used to determine the heat transferred with the heat capacity is Q equals delta T times Hc. The specific heat is the energy needed to raise the temperature of 1 gram of a substance by 1 Kelvin, or 1 degree Celsius. In order to use specific heat, we need to know the mass of our substance. The equation used to determine the heat transferred with specific heat is Q equals grams times delta T times SH, or specific heat. The heat capacity is the energy transferred divided by the change in temperature, while the specific heat is the energy transferred divided by the mass times the temperature change. There are two basic types of calorimetry. The simplest is constant pressure calorimetry, where the reaction occurs in the laboratory at atmospheric pressure. A simple calorimeter, like this one made from 2 styrofoam cups, is often used, and the reaction usually occurs in solution. Because the specific heat for water is well known, and a solution usually has a minimal effect on the specific heat, we can use the specific heat equation to determine the heat transferred. Since at constant pressure, delta H equals Q, we can find the heat of reaction per mole by dividing the heat transferred by the number of moles of the reaction that occurred. However, if high precision is required, or the reaction is a combustion, then the reaction is often done in what is known as a bomb calorimeter. The sample is placed inside a bomb, which is a rigid container, and the bomb is filled with oxygen gas under some pressure. The bomb is then placed in an insulated tub containing water with a very precise thermometer. The sample is burned with oxygen, and the energy is transferred to the water. The heat capacity of the calorimeter has usually been determined before the reaction is run, so the heat capacity equation is used to find the energy transferred. This occurs at constant volume, not at constant pressure, so the quantity determined is not delta H, but delta E. Calculations can be done to determine the value of delta PV so that delta H can be determined. The difference between delta E and delta H is usually not large.